In this video, we're going to factor binomials that can be factored using what's known as the difference of squares, which is a specific kind of factoring pattern. It says here, any polynomial of the form a squared minus b squared can be factored as quantity a plus b times the quantity a minus b. This is what's known as the difference of squares factoring pattern. So anytime we see a binomial that has a subtraction sign that separates the two terms, we should be suspicious and at least think and consider the idea that it could be a difference of squares and that we could factor it that way. So let's look at part A here, x squared minus 16. It's a binomial, two terms, separated by a subtraction sign. So I'm suspicious that it might be a difference of squares. So I think, okay, maybe I can factor it as, a plus b times a minus b. And now in order to do that, all I need to figure out is what the a is, what's being squared in the first part of the binomial, and what the b is, what's being squared in the second part of the binomial. This one shouldn't be too hard. What times itself gives you x squared? And the answer to that is x. So we're going to fill an x in the first part of each of these parentheses. And then the second question we have to ask ourselves is what times itself gives us 16? The answer to that is 4. And so I'm going to fill 4 into both of these. And there's the factorization of x squared minus 16. And you could quickly verify this by multiplying those two polynomials out, and you would see that when you simplify, you end up with x squared minus 16. Okay, next one. 49 minus y squared. Again, binomial, subtraction sign in the middle. I think, hey, difference of squares. So, what, when we multiply it times itself, gives us 49. That's 7. 7 times 7 is 49. So we'll fill in 7 in the first part in those parentheses. And then what times itself gives us y squared? Y. Y times y gives us y squared. And so there's our factorization of 49 minus y squared. 7 plus y times 7 minus y. A few more problems, a little bit more difficult on this page. First, 4x squared minus 25y to the fourth. So we've got two things, binomial, separated by a subtraction sign. So I think, hey, maybe this is a difference of squares. And I go ahead and try it out. And I ask myself, what times itself gives me 4x squared? Well, 2 times 2 gives me 4. And x times x gives me x squared. So 4x squared is the quantity 2x squared. And so I can fill 2x in as the front portion in both of these parentheses. And then I do the same thing with the 25y to the fourth. What times itself gives me 25y to the fourth? 5 times 5 gives me 25. And what times itself gives me y to the fourth? And the answer to that question is y squared. Y squared times y squared. We add the exponents. That gives us y to the fourth. So we can fill a y squared into both of these. And there's our factorization of 4x squared minus 25y to the fourth. Okay, looking at part B, we think to ourselves, okay, two terms separated by subtraction. Maybe it's a difference of squares. Set it up. We think to ourselves, what times itself gives us 36x squared? That's 6x. Then we turn to the 71 and we ask ourselves, what times itself gives us 71? And there is no whole number that when we multiply it times itself gives us 71. 8 times 8 is 64. 9 times 9 is 81. 71 falls in between those two. And so I can't find anything that when we multiply it times itself, any whole number that when we multiply it times itself gives us 71. So we would say that this one is not factorable. Or we would just go ahead and leave it as is. Okay. These last two problems are a little bit different from all the rest insofar as we're going to factor them using the difference of squares, and then something very interesting is going to happen in these problems. So we'll set up our difference of squares factorization. We ask ourselves what times itself gives us x to the fourth. The answer to that is x squared. And then we ask ourselves what times itself gives me 16y to the fourth. The answer to that is 4y squared. Okay, so far so good. Difference of squares. Now what you want to notice in this one that hasn't happened in any of them thus far is that this second factor is another difference of squares. And so I can factor that factor even further. What times itself gives you x squared? That's x times x. And what times itself gives you 4y squared? That's 2y and 2y. And so that would be the final factorization of x to the fourth minus 16y to the fourth. One last problem here in this video. X to the 16th minus y to the 16th. We're going to factor again. We're going to use the difference of squares since it's a binomial separated by subtraction. What times itself gives us x to the 16th? The answer to that is x to the 8th. And similarly, y to the 8th times itself gives us y to the 16th. And now again, that second factor is something that we can factor even more by difference of squares. And that's going to factor as x to the fourth plus y to the fourth times x to the fourth minus y to the fourth. And again, we see this third factor on the end where this is still a difference of squares. And so we're going to break that down even further. And that's going to be x squared plus y squared times x squared minus y squared. And whoa, one more time. We end up with a factor on the end here that can be factored more by the difference of squares. And so we end up with this being all these factors still staying here. And that's going to factor as x plus y times x minus y. And there's our final factorization of x to the 16th minus y to the 16th. So you always have to be on the lookout after you've used your factoring technique one time. Is there still a factor that could be broken down even more using that technique? So that's something to definitely keep in mind as we're approaching these factoring problems. Okay, hope you enjoyed this video, and I'll see you next time.